For the differential equation x dx plus sine squared of y over x times the quantity of y dx minus x dy equals 0, we cannot determine yet whether this dE is homogeneous or variable separable because it's not yet in the form m of xy dx plus n of xy dy equals 0. So what we need to do first is to group them together in this form. So we're going to distribute this. So x dx plus y sine squared of y over x dx minus x sine squared of y over x dy equals 0. So factoring out dx here, we have x plus y sine squared y over x dx minus x sine squared of y over x dy equals 0. And looking at this, obviously it's not a separable differential equation. And by inspection, we can see that both m and n are of the first degree, so we can say that this differential equation is a homogeneous differential equation. And n here is simpler compared to m, so we are going to let y equals vx, so that dy equals v dx plus x dv. So we're going to replace all y's and dy's here in the given differential equation, express them in terms of v and x. So substituting, that's x plus, we have y here, replace that with vx, and then sine squared. So since y is equal to vx, then therefore v is equal to y over x. So that would now be sine squared, so y over x, so sine squared of v dx minus x sine squared of v, and then dy is this one. So substituting, that's v dx plus x dv equals 0. So the next step is just to group together so that we will be able to transform this into a variable separable differential equation. So by algebraic manipulation, we have x dx plus vx sine squared of v dx minus, distribute this here, that's vx sine squared of v dx minus x squared sine squared of v dv equals 0. And these two right here can be cancelled out. So what's left is a variable separable differential equation. And so simplifying them and separating into two terms. So we have dx over x minus sine squared of v dv equals 0. And what's the integral? Next step is to integrate. And the integral of sine squared, so because the exponent is 2 here, we have to use the power reducing identity. So we're just going to copy dx over x minus, that would be 1/2 of 1 minus cosine of 2v dv equals 0. And so we can now integrate. So integrating dx over x, that would give us ln of x minus the integral of 1/2 here, dv, is 1/2 v. And remember that this is negative and negative, so that becomes positive. And the integral of cosine is positive sine, but we have a neutralizing factor here of 1/2, and then we have 1/2 here. So that would be plus 1/4 sine of 2v equals c. And then we have to go back to the original variable. So since v is equal to y over x, so replacing v with y over x, so that's ln x minus 1/2 of y over x plus 1/4 sine of 2 times y over x equals c. And the LCD here is 4x. So we're going to multiply both sides of the equation by 4x. So we have 4x ln of x minus 2y plus x sine of 2y over x equals c. So just to make it clear that we are not multiplying sine of 2 with y over x, so let's just put that inside a bracket. Or you can simply just write this immediately. You can just write this directly as, since v is y over x, so you can just write sine of 2y over x equals c. And so this is our general solution to our given differential equation.